So another concept we're going to study is that of the array slicing. It is similar to the concept we have studied, and it is rather a very important concept when we're talking about dataset and tensor manipulation in deep learning and machine learning. So it's very important to learn the use and the application of this concept. And as far as the syntax for slicing a particular array, a NumPy array, we're going to use the start, stop, and step. We have discussed the start and stop before when we were talking about lists, but we haven't talked about steps. So let's talk about that. So let's talk about 1D slicing. Before we hop onto the code on the right side, we're going to talk about the slicing type, which is the first one is we're going to start from x start colon. The x start basically tells us where we have to start the first index and where we have to. The end one suggests that the starting and the ending index of the array. Let's say that I have a starting point and the ending point. We're going to slice a particular section, a subset of that array, and we're going to display that. If you just want to have a starting point and read the rest of the array, we're going to just have a starting point and the colon. If you just want to have an ending point, so it will start from the very first element and it will go to the ending index for that, and so on and so forth. So let's look at the code on the right side. So if you want to read the first 5 elements, we're going to have an ending colon, which suggests that we need to read the first 5 elements. So if you want to read let's say the last 5 elements, or you can say the elements after the index 5, you will say that 5 colon, which tells us that you have to start from the 5th index and go till the very end. And if you want a subsection of it, you need to have both the start and the end. But we've already seen these concepts before. The new concept we're going to study over here in 1D slicing is the step function. This is followed by 2 colons, and what it does is that it takes n steps from the start, and the default value for that is 1. Let's look at an example. So the line number 20 over here tells us that if we have x colon 2, we're going to see that there is no starting or ending, but there is a step function that tells us 2. So it is telling us that read every index after skipping the next one. So it's telling us that read every other element. So 0, 2, 4, 6, 8, it is reading all the even index values. Let's suppose that you want to have the starting function for that as well along with the step function. So you will tell us that 1 colon 2. In this one we do not have an ending function, but we have the starting function. So you can also have the ending function, which would just follow that we have to start from this index and go to this one. But the step function tells us that the number of index values you can skip. So the default value of that is 1, which tells us that you have to read every other value. So you can take this step function as the increment value. Like you're iterating through that array, and that step function gives you that power of taking the jumps. So if it is 2, that means you're taking 2 jumps, and in every increment there is the addition of 2, and so on and so forth. So the thing is that the question you should ask yourself over here, and you should explore it by yourself, and whenever you're doing exercises in the collaboratory notebook, that what would happen if we use negative index for slicing? Now that is a very good question. If you have studied the concepts well, we saw that negative slicing is just a wraparound function of the normal slicing, the simple slicing. So you should be able to apply that over here and understand that it's not that different. You just need to have a broad view and a good concept to apply it. So considering the first example is that if we have a negative step function, what would happen then? In this example, we're going to see what happens in the step function. Let's just see that the starting and ending index is rather simple if you have a clear understanding of that, but the step function is a good question and it is a good practice as well. So I would suggest you go on your collaboratory notebook and try it out. We have seen 1D slicing, we have seen the concept of starting, ending, and step function, and now we're going to see the 2D slicing. We have seen 2D indexing, now we're going to see 2D slicing. So in 2D arrays, we have 2 orientation of information. We have the rows and columns. So what we're going to do over here is that we're going to use every orientation and we're going to slice it independently. For arrays, we're going to slice, and the concept over here is the same. The same concept is applied to the rows and columns individually. If you can understand and practice on 1D slicing, 2D slicing becomes rather easy. But the important thing is that you need to make sure what you want to extract from these 2D arrays. Now, considering this example, this one suggests us that the ending should be the first two. You can say that the first two arrays should be extracted, and the first three columns of these two rows should be extracted. So the first two rows and the first three columns of those two rows. So now we have the 12, 5, 2, 7, 6, 8. And we're going to use that. In the second example, we have the first three, you can say the rows. The step function for the columns is 2. Now this tells us that you need to select every other column, just like we saw before. So in this way, we have 0 and 2. Since you can say the number of columns is stored starting from 0 to 3, so the only two columns we can get from a step function of 2 is 0 and 2. Let's look at this beautiful visualization, which will give us a better and stronger understanding of this slicing. So the first, we have a 2D array of 3 rows and 2 columns. So the indexing is shown above the rows and columns as well. And now you want to read the first row and second column value, which is 2. So for that you will use 0, 1. Okay, that's pretty simple. Over here you can see that there is no comma and there is no slicing for the column value. In this particular case, when this happens, the column value will be default set, and it will mean that it will read all columns. Okay, so when we're saying that 1 column 3, we're saying that we need to read the first index row, which is the second row. So the one row, so you can say the second row, which is represented by the index 1, going to the third one. Okay, now the thing over here is that this is the third row, and we're starting from 1 to the last one as well. So okay, so you need to understand this visualization makes it quite easier, and you can see over here that we have read all the columns regardless, because by default we're reading all the columns when we're reading all the rows. So if there is no specification about the column, we're going to read all of them. Now the last one is it's rather simple. We're going to start from the first index, we're going to the second index, which is the second row, and okay, so it's not the index over here, it is the second row, the ending index value. And the column value should be 0, which means that we're only going to read the first column. So using this example, clear your concepts about columns, indexes, and different rows, and how we're going to slice them and how we're going to represent them. So let's talk about another very quite important method we call the reshaping method, which we use for reshaping arrays, so that we can use this method to reshape the size and the orientation of different arrays. So let's consider a grid, which we are going to arrange the grid by using this function, which creates a function of values ranging from 1 to 9, and we're going to reshape it by 3 into 3, which means that it has 3 rows and 3 columns, and we're going to print it. Now the idea of reshaping is something that if we want to change the orientation, so let's start from the basic example. Let's say we have a simple array of 6 values, and we're going to reshape into a 2D array of 2 rows and 3 columns. So we're going to use this particular syntax for that. So the important thing is that the product of the rows and columns should be equal to the size of the data. Okay, so if it's not equal, then it will not be appropriate, you can say the correct reshaping. So the question over here and the practice and the exploration part should be over here should be that what would happen if you exceed the values of the product? Would it give it an error or would it do something else? Okay, so but the rule of thumb and the basic intuition behind this is that whenever you're reshaping, the rows and column product should not exceed the size of the array. The last one suggests that if you want 3 rows and 2 columns, then you can do that 3, 2 reshape function does that for you, and so on.